This video is about the chain rule. So what we're going to do is we're going to find f prime of x given f of x in 5 problems. Then I'll give you 5 problems to practice. But first, if we have a problem like number 1, that's going to be pretty easy for us to do using old methods. So we can use the distributive property and the power rule and kind of figure this out. But then once we get to problems like number 2 and number 3 and number 4, well, those are definitely not using old methods. We can't do that. So what we're going to do is in problem 1, we're going to kind of experiment, see what the answer is, and then maneuver it back. So let's take a look. If we use the distributive property and the power rule and kind of figure out what's going on, if we write it as 4x squared minus 3x times 4x squared minus 3x, distribute all that other good stuff, we get 16x to the fourth minus 24x to the third plus 9x squared. Then taking the derivative of that, that's pretty simple. We get 64x to the third minus 72x squared plus 18x. So if I take a look and confirm this on Desmos, what I end up with is I end up with the original graph, f of x, and it's pretty clear that the derivative of f of x is equal to 64x to the third minus 72x plus 18. I mean, they were the same. So now let's go back, and if we had some intuition, what we might be able to do is take the original function and just try to take the derivative of the original function by taking this 2 and doing a power rule on the original function. I mean, that's intuitive. Let's see if it works. So 2 times 4x squared minus 3x. And that seems kind of intuitive. We would hope that would work. That would be really nice if it would work. And so let's go back to Desmos and see if this ends up being the same as the other ones. And it is not. I mean, that's pretty clear that it won't be because the 64x cubed is in the derivative, and we will definitely not get a cubed here. So it's not going to work. So we kind of have to figure out, well, maybe what's missing. And one thing that's missing here is if we take a look at the original, or if we take a look at the original function, if we take a look at it, there's a part in the middle that we haven't even accounted for. So there's this 4x squared minus 3x. What if after I take the derivative of this giant function, like the power rule, what if I take the derivative of the inside? So the 4x squared minus 3x. So let's take the derivative of the inside now. So 8x minus 3. And I kind of stick that on the back end of f prime of x. So I take the derivative of the big function, and then I take the derivative of whatever was on the inside. What happens if I multiply all that together? Well, you can check with the distributive property, but my guess is 2 times 4 times 8, that ends up being 64x cubed. If I take a look at all of the terms that I'll end up having x squared, I end up with negative 12 and negative 24, that's negative 36. Multiplied by that 2 on the outside, I get negative 72x squared. And then negative 3x times negative 3 is 9, times that 2 on the outside, I get 18x. It's actually pretty incredible that this works out that way, that if I take the derivative of the big function and then take the derivative of the layers on the inside as well, I end up getting that function. So what I can do is I can take a look at Desmos here. I can put the derivative of the inside. Notice if I use the power rule to take the derivative of 4x squared minus 3x, I get 8x minus 3. If I take a look at that, it ends up being layered right on top of the derivative. It's pretty incredible. So that is what we call the chain rule. The chain rule is if I have the derivative, if I'm taking the derivative of a layered function, so f of g of x, let's say, so a composition of functions. That's basically what the chain rule is. The chain rule is if we take the derivative of a composition of functions. I have the derivative of f of g of x that is equal to the derivative of f with that other function on the inside times the derivative of that inside function. Okay, so if I take a look at number one, if I were treating this like two functions, my function g of x would have been 4x squared minus 3x. And my outer layer function, my outer layer would have been x squared. So I take the derivative of this, which ends up being 2 times whatever's on the inside, and then I take the derivative of the inner layer, which was 8x minus 3. It'll be easier if we see a lot more problems with it. So number 2, given this, well, we clearly can't use the distributive property unless we want to be here all day. So my two functions are, I have something to the 7th power. So my outer layer function is x to the 7th, and my inner layer function is 3x minus 5x to the 8th. Okay, so what I'm going to do here is I'm going to take the derivative of the outer layer, so that's 7 times this thing to the 6th power. And then I'm going to take the derivative of that inner layer and multiply it to the end. So that ends up being 3 minus 40x to the 7th. So this is the derivative of this function. If you want, anytime you want to check to make sure you're right, you can take your original function, do d dx of the original function in Desmos, and then type your answer that you got in Desmos and see if these two match up. So that's a way that you can always check your answer. Number 3, one thing that we need to notice is that f of x has a couple things going on here. So it has two parts, so we have to take the derivative of both parts. Also notice that f of x has a product rule in the first part. So we have x times the natural log of x. So I'm going to take the derivative of the first part, which is x, and then we also have a second part, natural log of 4x squared plus 3. So derivative of the first part is derivative of x is 1 times the second part, natural log of 4x squared plus 3. Now I'm going to add that to the derivative of the second part. So the derivative of natural log of 4x squared plus 3 is 1 over 4x squared plus 3. This is a chain rule situation because we have another function that's kind of layered on the inside of natural log. So that's times the derivative of the inside function, which is 8x, then times the original x that we had here, because remember, we're in the middle of doing the product rule. So this is derivative of the first, which was 1 times the second, plus the derivative of the second function, that's all of this, times the original function. And now we have one more part to this. We have to take the derivative of tangent of 4x plus 3. Tangent's derivative is secant squared, and then times 4. And the reason we have to multiply it by 4 is we have another chain rule situation that 4x plus 3 needs to have the derivative taken of it. So if we clean this up a little bit, f prime of x is equal to natural log of 4x squared plus 3 or plus 8x squared over 4x squared plus 3 plus 4 secant squared of 4x plus 3. Number 4, given f of x equals sine of 4x minus 5 natural log of x, find f prime. So f prime of x, we don't have any product rule or anything in here, but we do have the derivative of sine is cosine. So we have cosine of 4x minus 5 natural log of x. Now we need to do the chain rule. So we're going to multiply this by the derivative of the inside, and the derivative of the inside is 4 minus 5 over x, because we have the derivative of 4x is 4, derivative of 5 natural log of x is 5 over x. So cosine of 4x minus 5 natural log of x times 4 minus 5 over x is that derivative. Last problem. We're given all this information, and that's a giant table. Find the derivative of f of g of x and the derivative of g of f of x. So basically, when you see a table problem, this is testing whether you actually know what the chain rule is without functions going on. So conceptually, we need to understand that the derivative of f of g of x is f prime with that inside function still in there. So the inner layer is still in there. Then we have to multiply it by the derivative of that inner function. Okay, so that's what's going on there. And in this part, we have g prime of f of x. Now, f of x is the inner layer in this part, times f prime of x. Now, all of these things are located at 4. So what we have to do is we have to make sure that we substitute 4 into everything. So f prime of g of 4 times g prime of 4. That's for this one. Oh my goodness. Look at f prime of g of 4. We have to actually see what g of 4 is. That's 8. So we have to replace g of 4 with 8. So I need f prime of 8 times g prime of 4. F prime of 8 times g prime of 4 will actually give me the answer to this one. So f prime of 8 on our table is 1, and g prime of 4 is 6. So I get 1 times 6, which is 6. Let's do the same thing for the g of f of x derivative at x equals 4. So I need g prime of f of 4 times f prime of 4. So I need to look at f of 4. So f of 4 on my table is 2. So that means g prime of 2 is what I'm looking for, times f prime of 4. So now let's figure out what those are. So g prime of 2 is 5. F prime of 4 is negative 3. So my answer to this is negative 15. So the derivative of g of f of x at x equals 4 is negative 15. I want you to try the 5 problems, and then I will put the answers up after the break. So here are the answers. The first one, f prime of x is equal to 50x minus 60. What you'll notice in all of these answers is that I tried to underline the first part of the chain rule derivative. So like the derivative of the outermost layer, I tried to underline that in blue. And then the second layer I'd underline in red. And the third layer I underlined in green. There's only one problem that has 3 layers, and that's number 3. Where you have secant of sine of 3x plus 4. So you have the first layer secant, the second layer sine, and the third layer is 3x plus 4. So number 1 is 50x minus 60. Number 2, you get 4x sine of 3 minus 2x squared. That's because you have the derivative of cosine is negative sine of whatever's on the inside, and then you multiply it by negative 4x, which is the derivative of the inside part. Number 3, secant tangent of that entire inside times cosine, because that's the next layer. The sine part is the next layer. So times cosine of 3x plus 4, then times 3. Number 4, I only underlined the blue and the red. That's because the quotient rule is actually involved there. So a lot of this really doesn't have any chain rule aspects to it. So the derivative of natural log of x squared plus 3 is 1 over x squared plus 3 times the derivative of the inside, which is 2x. Then, since it's a quotient rule, you have to do times the bottom minus the derivative of the bottom, which is 2 times the top, all over the bottom squared. And I didn't even simplify that great. I just kind of left it in. I mean, there's fractions inside of fractions, but you can simplify that further if necessary. Number 5 ends up being 9. It's because you take f prime of g of 10 times g prime of 10. And notice the g of 10 is 2. We'll go up to the chart and take a look. So since g of 10 is 2, we have to do, since we're doing f prime of g of x, that's f prime of 2, and then the chain rule part is g prime of x, and x was 10. So that's where we get 1 times 9.